In this video, I introduce a maximum entropy for imitation learning. Imitation learning is used to find the optimal policy from the expert demonstrations. Suppose an agent generates a trajectory zeta with a tilde, and based on M trajectories, we define a feature counts or feature expectation F with tilde. Here, F is the feature vector. Suppose the real-world function in Markov decision process is linear. So the real-world function R is equal to the product of the parameter theta and the feature vector F. This theta is what we need to find, and this feature vector is known. So the imitation learning to find the optimal policy in two steps. First, use the inverse reinforcement learning from expert demonstrations, find the real-world R. To do so, agent find a policy whose feature expectation is close to the optimal policy used by expert. When this policy is approached to the optimal policy, we find this theta. From this theta, we find the calculate this R. And in the second step, we use this R in the reinforcement learning to find the optimal policy. However, if expert cannot use the optimal policy because of the bias, variance, or dynamic environment, then we have, this are maybe we have multiple policies. We don't know, which policy will corresponding to this real world. To solve this problem, we define P is the probability distribution over the agent's trajectory. And then we use the maximum entropy principle to find this P and make this entropy maximum. This P satisfies the constraints. First, the sum of this P is equal to 1, and this this feature expectation from this P equal to the feature expectation of the expert policy. That means we need to select this P, make this term is maximum. That means make this delta is minimum, and in turn make this entropy is maximum. Here we not means we need to make this term is minimum because we have this this negative sign. And what we need to find a distribution. This distribution includes all the information we need, and then make this entropy maximum. Let's see how can we use the maximum entropy method to find the real-world R. To do so, let's define an objective function of the maximum entropy, like here. And this is this expectation of this log P. And now we can view this P as a likelihood in the Bayesian theory and satisfy this constraint. Then now we can, if we view this P is a likelihood, then we can use the maximum likelihood estimate from the expert demonstration or from the samples from the expert demonstration to train this model, make this likelihood maximum. That means we use the gradient descent method to update the theta using the samples from the expert demonstration. And step by step, make this theta is convergent. Once we get this convergent state, then now we can use it in the R formulation to calculate the real-world function R. Once we get this R from the maximum entropy inverse reinforcement learning, then now we can use this R in the reinforcement learning to find the optimal policy pi. For more details, please check with this reference. Thank you. Bye.